Tuesday, 24th, week 5, be day 9. Today was volunteer fair and tech club. Networking essentials, we talked about the course a little bit, and we talked a little bit about grades. At this point in time, somebody should be aware of where they're at in all their classes, not just classes they have in the IT area. Each teacher has a unique way to teach. Talk about you have to be persistent, have to have some patience with yourself, and you have to have the sense that you might get some things wrong when you try some things. You know, stick with it. And the concept of drive, the internal motivation, having autonomy in the work. The student actually learns. The instructor tries to create the environment, produce the information, but the student actually learns. We reviewed physical concepts, cables, design, and so forth. A little more in the OSI model. We configured Wi-Fi, and we got started in IP addressing. We reviewed a little bit of the OSI model, and we talked about the physical layout of a network. Talked a little bit about the next layer, Ethernet, the MAC address. We did some Wi-Fi also. So here's a scenario. If you we have a PC, processor, memory, storage, I/O, input, output, variety of that way. And then we could have a PC cabled, or we could have it sending a signal through the air. This would be to an access point, here to a switch. So we talk about these interfaces. You'll hear the term when we talk about networking, they'll talk about a host. The host would be a little more generic to where we talk about, in this case, we have two different interfaces to connect the end device. Some end device to a network. And when we connected, we get an IP address. So we have these two different ways of addressing the device. The IP address will be referred to as a logical address, and the MAC address is lots of times referred to as a physical address. It's not actually the physical layer, but it's referred to as the physical address in a device. Little review. Small business. We talked about possibly working with a small business in town to look at their networking. So we have a small business, and we have the connection in from the ISP. Point of presence, or sometimes referred as a demarcation point. So the ISP, the main distribution facility. And then internally we might create an intermediate distribution facility in order to distribute that information. These would be called vertical runs. You can create one more vertical run to another IDF, but you shouldn't create any more in a chain. for security reasons, for troubleshooting reasons, and performance. In fact, typically you're better off, if you're going to create them, if you can, to run it from here. If you're going to create another IDF. Alright, then from the IDFs we have what we refer to as horizontal runs going to our end devices, for example. And you can have some out of here, but typically if they do that, then they say inside the MDF is an IDF, Intermediate Distribution Facility. So, and these could be wires or they could be access points distributing, which then allows our endpoints to connect in. Or what we call often our end devices. We're going to do some work in a tech den, which will talk about how we punch down these connections. And how we run those through the walls and so forth. Okay. IP addressing. So what we did was we grabbed addresses from devices. This was a address directly from a provider. We had a student check their phone and they gave us this address. I don't remember who it was, but it might have been Hunter. Gave this address. This is a public address. Public address that can be used out on the internet. Now these other addresses, this one was from somebody's phone internally, a private address here at NIAC, which then gets changed to a public address if and when it goes to the internet. This one was from my phone. Okay. So even though we are connected to the same access point, we're on different networks. Alright. Then we talked about, we have the address and the subnet mask. The subnet mask divides off which part of the address is the network and which part then is referred to as the interface. Or we'll also hear the word host. So host was the more common one in the past. In the future we're talking more about an interface from the device. Base 10 number system. 10, we have 10 digits that we use to represent base 10. So we have groups of 10. So we have 10 to the 0, which represents 1. I'm going to switch here, colors. 10 to the first, which is 10. 10 to the second is 100. 10 to the third is 1,000. So here we have 4,130. Right? We have 4 groups of 1,000, 1 group of 100, 3 groups of 10, and 0 groups of 1. Here, I don't know why I used all ones. We have 1 group of 100, 0 group of 10s, 1 group of 1s, so 101. Going smaller decimal, 1/10th, 1/100th, 1,000th. So we can go infinitely small, we can go infinitely big using this number system. Now, in a computer, it's base 2. That's base 10, base 2, so we only have 2 digits, 0 and 1. We refer to that as binary. A binary digit is a bit. Typically 8 bits gives us byte. So here's 8-bit examples. 2 to the 0, anything raised to the 0 power is 1. 2 to the first is 2. 2 squared is 4. 2 cubed is 8. 2 to the fourth is 16. 2 to the fifth is 32. 2 to the sixth is 64. 2 to the seventh is 128. Alright, so then we did an example. If we have 0 groups of 128, 1 group of 64, 0 groups of 32, 16, 0, 8, 0, 4, 0, 2, and 1 group of 1. We have 1 group of 64, 1 group of 1. That gives us a 65. Using ASCII code to represent like text, these 1s and 0s represent an A. This group of 1s and 0s represent a capital B. This is what's in the computer. That's what's being used in the computer. It's either, if it's on a magnetic disk, either there's a spot or no spot magnetically. If it's on a DVD-ROM, either the spot's burnt there or there's no spot burnt. If it's in RAM, there's some way electronically, whether it's representing the 1 or no 1. The processor processes the 1s and 0s. Okay. Now for humans, it's hard for us to be able to see that or manage. Okay, so finish up. We will continue to work on the OSI model. And how this converts into TCP/IP model, the application layer, transport, how we send the data, how we address it logically, IP addressing here they call it the internet, and these two layers together, network access. So our emphasis is going to be continue on these two layers for the next 2 or 3 sessions, dealing mostly with IP addressing. That's it.